All right, guys. Welcome to the first PowerPoint of WT70. Okay, upon completion of this module, you will be able to identify and explain shield and metal arc welding safety, explain welding current, identify welding power supplies and their characteristics, explain how to set up welding power supplies, and set up a machine for welding. Identify tools for weld cleaning. We'll have to set up an SMAW machine. That's the performance task. Okay, SMAW safety. Moving welding equipment. There can be electrical hazards, lifting hazards. Always remember to use taglines when hoisting heavy objects that tend to spin or swing. There can also be dangers when working at heights, and then just the general dangers associated with welding. Okay, the welding current. The arc that is produced during SMAW is an electrical current that jumps across the gap from the tip of the electrode to the surface of the workpiece. If the electrode tip is touched and held against the workpiece instead of allowing for a gap between the two, the electrode will pass the electricity directly to the workpiece without creating an arc. So basically, that's when you stick an electrode. Okay, there are two types of welding current. SMAW power supplies are designed to produce an output that is nearly constant current. The standard frequency in the United States is set at 60 cycles per second. Okay, so here's two different setups for DC welding. You have DC electrode positive and DC electrode negative. What we do in our shop, most of what we're doing is DC electrode positive as far as the stick welding goes. We tend to call the workpiece clamp the ground clamp. Just remember that it's the workpiece clamp because it can be on negative or positive, just depending on which setup you're doing and what process you're carrying out. Okay, these are volt amperage curves that we look at when it comes to welding, and you can affect the placement on this curve based on arc length while welding. If you guys get a chance while one of your friends is welding, watch the amperage readout on the machine. Changes in arc length will change the stability of the arc, and they'll also change the amperage reading on the machine. If you notice while welding, it will fluctuate. Okay, the primary current required for welding machines can be 120 volt or 240 volt single phase or 480 volt three phase. Transformer welding machines use a voltage step down transformer which converts high voltage low amperage current from commercial power lines to low voltage high amperage welding current. So basically a transformer welding machine is just when you convert energy, electrical energy, you always have the same amount of energy, just whether it's volts or amps, it's still going to be the same total amount of energy. And so with that transformer machine, we want the high amperage. That's what gives us the ability to create the arc, but we don't need the voltage necessary like we do in our transmission lines. Okay, transformer rectifier welding machines. A rectifier is a device that converts AC current to DC. A transformer rectifier machine uses a transformer to reduce primary voltage to welding voltage and then rectifies the current to change it from AC to DC. Okay, here's just a little example of how this works. You go from your primary input voltage, from your primary power lines to a transformer, then to your electrical box, fuse box, then to your outlet, then to your welding machine. Okay, if no welding is required for 30 or more minutes, stop the engine by turning off the ignition switch. So when we're using gas or diesel powered welders, we don't want to just let them idle if we're not welding. Also in California, there may be other restrictions based on California Air Resource Board requirements. Okay, SMAW machine ratings. The size of a welding machine is determined by the amperage output of the machine at a given duty cycle. The duty cycle is based on a 10-minute period, the percentage of 10 minutes that a machine can continuously produce its rated amperage without overheating. Okay, so when we're welding with stick welding, really a high duty cycle for a stick welder is usually about 60%, because the time you spend changing rods and cleaning welds ends up eating up the time. So you really don't need any duty cycle higher than that for an SMAW machine. Sometimes in production welding, when they're doing wire fed processes with robotics or in production, they're going to be closer to 100% duty cycle because there's less cool down time between welds. Things are happening much faster. Okay, welding cable. They carry welding current and are designed for maximum strength and flexibility. Conductors inside the cable are made of fine strands of copper wire. The longer the distance the current has to travel, the larger the cable must be to reduce voltage drop and heat caused by electrical resistance. So if you have really long welding leads, you'll actually have less power coming through them if you don't have them sized correctly. This isn't only true about welding leads. Also, like hoses on an oxy-fuel torch setup, if you have a long distance to go, you need larger hoses so that you don't lose, because you can have significant pressure drop in hoses as well. Okay, here's a breakdown of the basics of a welding cable. Fine strands of copper with a rubber reinforcement and an insulator. Okay, recommended sizes. So if we look at our amperage range there, as you notice, this cable's given and the sizing's giving as a number. The smaller the number, the actually larger diameter the cable is. And so, 200 foot of, if you need 200 feet of lead, 200 to 250 feet of lead, and you want to be able to run 200 amps, at a 60% duty cycle, you need 1/aught cable, which is pretty good size cable. Okay, here's some different lugs and quick attachments. On our welding machines, you guys may have noticed already, we have a twist lock attachment that's standard to Miller. There are a few other different styles, just kind of depending on what setup you have or what you're trying to accomplish. But the lugs on the very top, those a lot of times go on engine-driven machines, and they make lugs that bolt onto the machine, and then quick disconnectors that just attach directly to those lugs. Okay, workpiece clamps. So a few different styles here. We have the low current clamps, which are like what we use in the shop. High current clamps, a little heavier duty. Rotary ground clamp. This allows the ground to move, or it allows the piece to move. So if you're welding on something that's spinning, it would allow that to move without getting the cable tangled up. And then a magnetic swivel clamp also. Okay, some different electrode holders. So the collet type electrode holder. These are nice when there's limited room where you're welding. One issue gets to be if you tend to burn electrodes really short, you can actually damage the collet inside to where you won't be able to tighten the rod all the way in or loosen it up enough to get larger electrodes in. It's also kind of nice because you can clamp the rod in and then kind of bend it to the exact angle you need where you're the most comfortable. Clamp type electrode holders are by far the most common. The jaw opens up, the top jaw is smooth, the bottom jaw has grooves in it, so that you can hold the electrode firmly at different angles. Okay, here's an example of some weld cleaning tools. I think we're all pretty familiar with wire brushes, chipping hammers, and files. Okay, needle scaler and a weld slag chipper. So what a needle scaler is, it's a pneumatic tool that has a bunch of small metal pins in it. And when you hold it against a surface and actuate the lever, those pins hammer back and forth. And it works really well for cleaning welds and also for cleaning rust from material when doing weld repair. And that's all, guys. Make sure and complete the quiz and discussion post for this module. Also, you'll notice there are some videos posted for lab demonstrations. Be sure and review those also if you have any questions.